Okay, students. Today I am going to discuss about 4A, which is plotting the root locus of plotting the root locus with P controller using MATLAB. This is what I am going to discuss today. Okay, so I have written down this thing. This was actually our plant, which was actually given to you. So the plant is actually over there. Okay, so you have this plant, you have got the transfer function 1, transfer function 2, transfer function 3, transfer function 4. And if you solve it, you will get this thing. Okay, 1 over ls plus b. This is transfer function 2, transfer function 3. This is transfer function 4. And I am now taking TD 0. Okay, because when you are plotting the root locus, you have to take the 0. Now what I've done, I have combine this block, and this block together. Of course, when TD is 0, this is going to be a straight line. This summation sign is going to go away, and you are going to get this thing, K over Ls plus B. This is uh, this is basically R. Okay, so this is R. So this is my mistake. So make it R. Ls plus R, Js plus B, and then you have KB over here. Now, we are going to make the closed loop transfer function of the plant. Remember, this is the plant. We do not have the controller over here right now. So this is only the plant. So closed loop transfer function of the plant can be found by using this formula, GS over 1 plus GS HS. So this portion is GS, this is HS. So this is GS and this is HS. So you can put everything over here. And when you do all the simplifications, you are going to get the closed loop transfer function of the plant like this. Okay, so you can do the simplification and you will get this thing. Now this is actually the plant. This is the plant which is over here, and of course this plant has got an inside loop. Okay, that's why I have called it closed loop, because it has got an inside loop. But this is the plant and this is the P controller, which is KB, and again we are going to have a feedback in this system. Okay, so we are having a feedback of the system as well. Now why I'm saying a system, because system is made up of plant and controller, and it has got this feedback as well, which is done by sensor. Okay, so now this is P controller and this is the plant which is written over there. Now open loop transfer function of the system is actually this thing. Now if you come back to the Ogata, you are going to see that what actually an open loop system is. So if you come to the Ogata, where it describes about open loop system. So open loop. Okay. So over here it's telling you what an open loop system is. So look, this is GSHS. So what is open loop system? Open loop system is the product of this GS and HS. This means that you are actually cutting the signal from here. Okay, you are removing signal from here. What you are going to get? So you will get GS multiplied by HS. Okay, so this is open loop system. So you can locate the poles and zeros of GHSS. So GSHS is actually the open loop system. Okay. So now we have to actually find the open loop system or open loop of the system. Remember that there are the closed loop of the plant is different thing and closed loop of the system is different thing. Okay, so closed loop of the system is going to be a single block for this whole thing. Okay, and open loop of the system is this one multiplied by this one, which is actually this thing. Okay, so you multiply this KP with KT over JL, you are going to get this open loop system. Remember, this is GS, this whole thing, this one multiplied by this one is actually GS, and HS is actually 1 in your case, because there is no block over here. Okay, So HS is going to be 1. So now what I've done, I have made this thing on MATLAB. So when I come to MATLAB, I have got this. This is 4A. This is not 5A. Okay. So this is 4A, clear CLC, clear all, close all. These are all the values which I have written. J, B, KB, KT, R, L, everything I have written over here. And this is the value of KP which I have taken. Because we are going to change this value, we can change this value. Now, we know the transfer function 1. Okay, transfer function 1 is 1 comma LR. As we know, this is actually the transfer function 1. This is TF1, 1 over LR. This is R actually. And then we have transfer function 2, KT only. Okay, 1 means at the denominator you have one constant 1. Okay, and the third one is 1 over JS plus B. And the fourth one is KB only. Now, feedback is actually the command to make the closed loop transfer function of the plant. So you are going to use this feedback command TF1 multiplied by TF2 multiplied by TFT comma TF4. So what is actually at the HS side is TF4, okay, which is actually KB. So you can come back over here and you will see that this is TF1 multiplied by TF2 multiplied by TFT, and this is HS. So you are going to write this HS, which is TF4 after the comma. And because it's a negative feedback, as you can see, its negative sign is over there. So you will write -1. So -1 tells that you have got a minus sign at the feedback. So this is going to give you, this feedback function is going to give you the transfer function plant closed loop. This means it is going to give you this thing. Okay. So this whole thing, closed loop transfer function of the plant. So this is actually calculated. Now you can see how easily we calculated using MATLAB. This whole thing is now calculated. So this means this thing is also calculated. This and this is, they are same thing. Now, PI controller is actually KP, which is actually over here, KP. I have substituted the value of 100 over here, but you can substitute any value over here. So what is transfer function of the closed loop? Transfer function open loop. So it is PI controller multiplied by transfer function plant open loop, which closed loop, sorry. So this is actually closed loop. And you have got this PI controller, you multiplied them together. And then what you'll do, this is transfer function system open loop, and you have placed it over here. And you are going to use the root locus command. Now, when I run this, I'm going to get this graph, and this graph is actually the root locus. Okay, so these cross means the poles. So the poles are going up like this, and the poles over here are going over here. Remember, this is 0 line, and this side is the left half plane, and on the right side of this 0 line is right half plane. So you will see that no matter what gain you have, when you click over here, you will see that the gain is actually increasing. The gain is 0.000375. The gain is increasing, and it can increase. If you increase the size of the graph, it's going to go up in this direction, and it's going to go down in this direction. So remember, over here you have this gain, and over here you have this gain. Okay, so what is gain? 0.016, and over here 0.0164, same. So remember, the gains actually, I mean, both the roots move. I mean, for a particular gain, the roots are going to move outward like this. Okay, in both cases. Okay, so you are actually having two roots, but this is going to be the damping, and this is going to be the overshoot for this value of gain. Remember, even if I change the gain, this is not going to change. The graph is not going to change. Look, right now over here the gain is 0, and over here the gain is 0. So you can see that at zero gain, what we have? -1 52 and minus 134.1. Okay. If I change this value, if I change this 100 to, for example, 2, and run the root locus again, you will see that again the graph is same. The graph is not changing. Minus 152 plus 134. This one is minus 152 minus 134. If I change the value of k again, for example, make it 5, and I run it, again you get the same graph. You get the same graph, as you can see, minus 132 minus 1 minus 152 plus 134, same graph. So this means that this is the root locus is actually not dependent on the value of kp. Okay, it is not dependent on the value of kp. Okay, so you can choose any value of kp. Normally we do not consider kp. We say that okay, kp is 1. We do not consider kp, and we just in over here we do not write, we just write tf plant closed loop over here. Okay, so we do not add pi controller, which is actually kp. So even if you write tf plant closed loop over here, you are going to get the same root locus. Okay, so this is actually the plot which you have to make, okay, and this is the root locus plot. Okay, thank you.